Welcome everyone. My name's Adil, as has kindly been introduced by Vanu. We're going to be going over an introduction to cloud computing. So we're going to explain what in the world is this thing called cloud. Some of you might have heard of it. Some of you might already be using it, and you might not even realize that you're using it. So we're going to go through kind of an overview of this thing called cloud computing, and why it's really important to a lot of organizations out there that are using it right now. Okay, so let me just move forward into the slide. There you go. So a bit by myself, Anna already introduced me, but I work to actually make cloud education a little bit easier. At least that's kind of my thing. That's what I do. I talk about cloud a lot. Basically, everything I do is basically involved in the cloud, which is fantastic. So I teach about cloud. I also make cloud labs, which are basically hands-on environments to learn from. So I think many of you who've come to this session learning about cloud may not know much about cloud and how to learn about cloud as well. So not only including this session, I would really enjoy if people can ask questions on things that they're confused about in cloud. What do you know about cloud as well? Let me know yourself and ask questions about cloud, which would be great. I will, of course, near the end when we do our Q&A session, I'll be telling you about places where you can go out and learn about the cloud. Okay, so that kind of fills into what I do with the cloud and kind of what this session is entirely about. So let's kind of, before we talk about cloud, let's think about what are organizations out there trying to do. Okay, there are organizations trying to do a lot of things. The biggest one is they're trying to make money, right? What they're making money off, we'll talk about. But organizations, especially organizations that are tech-based organizations, they might create a product, maybe a software as such. Let's call it an application. It might be a website. It might be an application that you're using on your phone, for example, right? They typically are trying to find a way and a place to put this application so people can use it. Okay, let's talk about web apps, websites basically. Websites are based on the internet. You go onto the browser, you go into a URL and you access that company's website, right? And that is public. Everyone can go about accessing it. There are private ones as well, but let's talk about the public ones. So when you go about accessing this website, it's a publicly accessible site. So putting the background of that is organizations are trying to find a place to basically put that site, or host that site, or host those web applications, right? But they may also be writing these applications in ways that you might not be familiar with. I mean, typically when you think about creating a website, what do we usually think about? Maybe your Wix.com, maybe your Squarespace, not sponsored, but those are the kind of places you go. You go to website builders, right? And you kind of just do everything there, but that doesn't give you the real customizability of actually creating these web applications or websites from scratch. And typically these applications or websites, they're written in some kind of programming or coding language, whatever it may be, right? And so then these organizations need a place to host these applications. We're going to speak a lot about this particular thing today. But also these organizations might have some kind of infrastructure. Now, we're not talking about the physical buildings and the pillars that are holding up their headquarters. We're talking about the technology that's holding up their organization. That could be maybe words you've heard of before, like servers and databases and storage. We're going to be speaking a little bit about that today. Organizations might have data they want to analyze. They want to get out meaningful information from it. So these are all things that organizations are trying to do and utilize technology to do that, because that's how they provide a product, a service, and that's how they create money and revenue for themselves. Okay. Why does cloud come into this? Well, we're going to speak a little bit about that just now. So cloud computing is about getting all those computing services that we might be familiar with in an organization. Now, for any of you who's actually worked in an office before, you might have seen the IT team run away into a secret room that only they have access to, right? They use their key cards, they go in and they hide away. And if you've ever caught a glimpse into that room, because I know when I used to work in support, a lot of people always tried to find out what was in that room, right? Whenever you'd run away into that room, you might have seen a glimpse of like jet engine noises and these big, huge, bulking machines, and wondering what is in there, what is going on in there. The IT team's clearly having a lot of fun, right? With all these big technologies. In those rooms, we're going to call it a server room. In those rooms, they have these big computers, huge computers, very similar to the laptops and PCs that you're using right now, actually. But let's think of it on a massive scale, on an enterprise scale, that an organization wishes to run their organization from, because they will be running their internal applications, maybe even their publicly hosted applications on. These servers, what we call them, they're basically just computers. And they have all the things that you're familiar with a computer. Maybe a storage, some kind of processing unit, a CPU, right? Maybe RAM, memory, to be able to run many concurrent applications at any one time. Or maybe you have a really hungry application like Chrome that really loves to eat through your memory, right? So think about your PC, but just on a really, really big scale. So those computers, and you'll have lots of them as well. Those are the kind of things you'll run on premises. That's where your organization has their own room dedicated to these computing services. Cloud computing says, well, what if we don't want to host it anymore? Well, what if we don't want to manage all the problems associated with hosting it? Let me ask a question to everyone now. Let me do a quick, very short Q&A. Write it in the chat, please. What do you think are the cons, the negatives, with having your own on-premises server room or data center, which is an entire building, dedicated to these computers, these huge, big computers? What do you think are the negatives associated with? Let's read through. It could be costly. Let's expand on it. What kind of costs do we think that could be associated with that? Availability. Okay, let's expand on a bit about availability. What does that mean? Management, I like that. Management's a good one because when you're talking about maintenance and management, you're thinking about, oh my God, now I own these computers. I've got to be the one responsible for making sure those computers are up to scratch, are working. I've also got to pay the people to do that as well. So there's a lot of costs and stuff associated with that. It's a headache, absolutely. Costs are a good one as well. The cost, I think I wanted everyone to expand on a bit more, and I'll give you a clue. What about electricity costs? You've now got to power all these computers. What about the networking costs? You've got to make sure all these computers are networked. Security, you've got to manage the security, absolutely. So there are huge cons and negatives associated with having your own on-premises, private data center or server room where you have all of these computing services there ready for you at hand. Now, there are benefits, of course. There must have been a reason why organizations have and maybe still do use something like on premises. And we're going to go through that in just a short while. But what we're saying is, let's think about, you know what? I vaguely remember when I used to work in an organization, when my computer had troubles, who would I contact? I'd contact who? When I had a problem with my computer, who would I contact to help fix my computer? Help desk. Absolutely. IT support, right? Tech support. And sometimes tech support wasn't always with you. Sometimes tech support wasn't always with you. So let's imagine, I hope I can draw my computer here. Oh, it's a very terrible computer. Let's imagine I have my laptop here. And tech support, who's all the way in maybe another country, they'll tell me, well, okay, could you, let's take over your computer for a second. Let's just remote into your computer. That's what the technical terminology is. Let's remote into your computer over the internet. That Pokeball looking thing is the internet. Okay, and what they'll do is they'll start to control your computer remotely. So we kind of get an idea that there is a way for us to access a computer over the internet. And effectively, that is what cloud computing is. In a kind of very crude way, cloud computing is about accessing computing services, except you don't need to host all that hardware anymore. Now what you're saying is, let's let someone else host it. Let's let a big company, they can manage all of those cons that you just spoke about, everyone. And thank you for everyone for your suggestions and recommendations. All of those problems that we just spoke about, costs, electricity, aircon, maintenance, we're going to let someone else deal with that. Cloud computing is, we can access that over the internet. It's almost like renting it, if you think of it that way. It's like renting hardware. All right. And there are different service types associated with cloud computing. So when you go and you're borrowing, almost, you're renting out these computers, these servers from another organization, you're asking them, hey, I kind of just want a computer to use. Could you just spin that up for me? They'll spin it up for you and you get to use it. And you can even decide how powerful that computer can be for you. Now, I'm using the word computer, I'm using the word server. Typically, in this situation, we might use the word virtual machine, but this isn't the situation or the course or webinar to even to speak about virtualization. You can spend a whole hour just dedicated to virtualization. All right, but we can use these servers just through our web browser. And we don't need to manage all of those costs and those headaches that we were speaking about by maintaining our own server room. And we also then open up space in our on-premises headquarters in our organization, because now we can put other people there and they can work there and I can have tables, etc. So there are huge pros to using something like cloud computing. And what other kind of computing services that we can use? We'll go through, but some of them mentioned here: databases, networking, maybe some software as a service, something that's already ready for us to use straight away. In recent times, we've seen a huge influx of artificial intelligence and machine learning services, and potentially there is an opportunity sometime in the future to spend a bit more time on those particular buzzwords, AI and machine learning. But for today, let's talk about what cloud computing is and what are its benefits. Cloud computing has a bunch of benefits associated with just moving it to somewhere else. As soon as you go somewhere else and let them deal with it, you already have the cost benefit. You also have the benefit of scalability. This is a really good example. I'm hoping that I can share my whiteboard because I want a good example of how and what scalability is, because I think it's really important to understand that. A lot of the time when we talk about cloud, for those who may be learning cloud for the first time, you hear these buzzwords, these kind of technical jargon words like scalability, flexibility, predictability, and because they all have ability at the end, they all sound the same, right? We're going to go through one of them right now in a bit of detail. I'm going to share my screen to my whiteboard. Share it now. I want to spend a bit of time just speaking about that. Can I just confirm everyone can see my whiteboard there? Fantastic. All right, so let's imagine you currently work at Tesco's. I'm going to turn on enhanced shapes. You currently work as a manager. That is a very terrible square. I hope that it does not. Let's try that again. This graphics tablet is not that great. There you go. It worked out. Okay. Here are tills at Tesco. Okay, let's have another one here. Okay. Another one here. Okay, you're a manager at Tesco's. And right now, you currently have one person on tills. That person is looking after just a couple of people who are currently in the shops. Okay, one person here, one person here. So you can say that there's not a lot of people in the shops. That one cashier can actually deal with that couple of people who are in the shops right now. Suddenly, the football game finishes. West Ham's just won, and you have an influx of people coming into the shop. And immediately you realize that there are way too many people to deal with. And they all currently have to be dealt with by this one cashier. What do you as a manager do in this situation? What do you as a manager do in this situation? You're a manager at Tesco's. You have one person on the tills, and they have to deal with all these people. What do you do in this situation? Type in the chat, Let's have a look. You add more staff. Okay, you add more people to tills, right? Helping out, for sure. You open up more tills, call more staff. Absolutely. Good stuff, good stuff. So now we're going to basically say, okay, well, to deal with this, I'm going to need to have more people on tills. And what ends up happening is now we can have a couple of people go in there, and maybe these people go in over here, and maybe some of these people go over here. And now immediately what we're seeing is we're going to be able to deal with this demand, right? Scalability is basically what we've just discussed here. This is the idea that when there's an increase in demand, right, we are able to increase the number of resources, or maybe even the performance of an individual resource, right, to deal with that demand. And one of the benefits of using the cloud is, let's say you're using a website, right? Let's say you shop on like a retail store. Let's say ASOS, for example, a store that gets a lot of traffic, right? Or in Sports Direct, maybe they get a lot of traffic as well. A lot of traffic. In fact, you know what? Let's make it even better. Nia is a website, right? Okay. Let's say Nia gets a lot of traffic. You want to make sure that Nia can handle a couple of people, but also in certain periods, maybe there's an influx of jobs that you can find on Nia. Go to nia.ai and find more. You want to make sure that even when there's an influx of more people, that the website doesn't go down, doesn't slow down, doesn't crash, right? To deal with that increase in demand, you need to be able to have some kind of scalability. The cloud has innate scalability and has the ability for you to turn on some additional scalable features like auto scaling, such that if the demand was to go up at any one time, you can automatically scale up or out and deal with that demand. Just like you just did in Tesco's right now. You had more people coming into the shop and you dealt with that demand by adding more resources, by adding more people. So imagine, for example, you hosted this website somewhere in the cloud. Now you want to be able to deal with that demand. Maybe you increase the number of resources to do so, be it manually or automatically. So these are some of the benefits. I've also just mentioned one, being scalability. There are various other benefits as well, but these are just some of the benefits that you can have with being in the cloud, including scalability. We have flexibility, reliability, even security as well. All right, let's move on. Now, because we've actually given these servers, we've actually given the responsibility of these physical machines to someone else now. Think about it, we've kind of shifted our responsibility. We've kind of said, well, I don't really want to worry about the physical stuff anymore. Let me give it to someone else to deal with. This is where the shared responsibility model comes in handy. This is actually a widely used model. The picture that you're seeing in front of you is a chart taken from Microsoft themselves. However, this applies to every single cloud provider out there. We haven't spoken about what cloud providers there are, but let's just say Microsoft have a cloud right now, okay? When you use the cloud, or when you want to use cloud services and you say to Microsoft, hey, I want to use a server, what you're saying is, I don't want responsibility for some stuff. Can you deal with that instead? And so the responsibility shifts, or we can say it's shared between you and the cloud provider, between you and the cloud provider. So you can see on this diagram here, we have, where is my, oh, there is, just wanted to make sure that was working. Let's go over here and just rub that out for a second, eraser, and there you go. Okay, cool. Just wanted to make sure it was working. Okay. So we have on the bottom here, or actually, let's talk about this right column here first. This column on the right, you can see it says on-prem. We spoke about this earlier, it was on-premises. That's where we had our own server room. In dark blue, all these dark blue things that you see here, these are all the responsibilities that you retain as a customer. All of them. Whenever it's dark blue, the legend is over here for anyone who's interested. Whenever it's dark blue, that means you as a customer retain that responsibility. You as a customer retain that responsibility. And that makes sense. On premises, you are expected to deal with absolutely everything from cost to maintenance to security, right? As we start to move into the cloud, depending on which cloud service type we choose to use, so depending on what we're specifically asking to use from the cloud provider, determines how much responsibility we keep or we retain and what we actually give away to the cloud provider to deal with, right? So these three words that you see here, which I am going to go through, so don't worry about it. Just imagine that this is basically us using the cloud, right? It's all about the cloud right here. You have on-premises, your own server room, and then you have the cloud. And so with this cloud, we have three different service types, depending on which one we choose. So depending on what service type we choose, determines how much we retain and how much we give away. If I choose this one, which you wouldn't pronounce as letters, you'd actually pronounce as a word. So you pronounce it as IS, right? Sounds weird, but that's how you pronounce it. Same with the other one, PAS and SAS. That's just how you pronounce it. Don't say IaaS, a bit funny. IS, okay? With IS, and it stands for Infrastructure as a Service, and that's going to be our next couple of slides. So I'm going to go through it in a bit more detail, so don't worry about that. With IS, we actually say, okay, I retain all of this responsibility, no problem. I clearly have to make sure the operating system's up to date for whatever, maybe it's a server, for example, right? I have to make sure the operating system's up to date, it's patched, there's no problems with it. Any applications I install on that server, maybe that's my responsibility as well. But I just don't want to deal with the physical stuff. I just don't want to deal with it. Okay. These are the kind of services where you give away the physical stuff to the cloud provider and they'll deal with it. But I have responsibility from the operating system upwards. Okay, so all of this stuff is my responsibility. I realize there's a lot of red going on, so let me try and rub out what's not necessary. Okay, so that's what's happening here in the case of IS. I'm saying I'm responsible for the operating system upwards, but I don't care about the hardware. What if I want less control? And this is where what I've written on the left-hand side, how much do I want to control? How much control do I want? Okay, how much control do I want? If, for example, I wanted less control, you know what? I don't even want to worry about the operating system anymore. You can see that here, right? I don't want to worry about the operating system anymore. Then on top of having the responsibility of the hardware, the cloud provider can also just take responsibility of the operating system. Maybe I just want a platform onto which I can just build and deploy my application. I don't really want to worry about anything else. I just want to build and deploy and test my application. Something like PaaS is something that we're going to speak about where you can do that. And same thing with SaaS. You are giving more responsibility away to the cloud provider in this particular case. You're saying, you know what, I don't even want to worry about the application configuration. Just give me an application that I can just run straight away. What are some examples? We're going to go through it in just a second to see something in the chat. Okay, cool. All right. Let's move on to the next slide. So those are the 3 cloud computing models, or what I like to call cloud service types, that you can potentially use. It starts off with infrastructure as a service. Okay, very bluntly, or very simply, infrastructure as a service is just about providing that baseline computing stuff. It's about renting the hardware almost, right? You can just give this server, for example, a virtual machine, give some storage, maybe some infrastructure for networking to piece services together. That's infrastructure as a service. Platform as a service is, okay, I want a place where I can actually just not worry about the operating system, like in a server, for example. I have this application that I've coded, maybe with some other features as well. And I just want a place to be able to deploy and develop it. Can you give me that? That's platform as a service. Then we have software as a service. These are pre-built applications. So those are the 3 cloud computing models that we spoke about in our shared responsibility model. Whenever you're talking about cloud computing, you have to refer back to the shared responsibility model, because if there's an issue, you kind of need to remember, well, who had responsibility of that? Was that my responsibility? Was that responsibility of the cloud provider? And to talk about in kind of real life terms, this stuff really happens. There are organizations that say, that use cloud services. Let's talk about AWS. They have this storage service known as S3. Okay, just imagine it kind of like your Google Drive. You can put files and stuff there. It's way more complicated than that, of course. But they have this service. And when this organization, many organizations, in fact, when they configure this service to use, they left their storage buckets open to the public. And they found out that all of the data that was there was publicly accessible. And so they started to really screw at the cloud provider and say, you just left all my stuff open. Anyone can access it. This is your responsibility. And the cloud provider comes back and says, no, in fact, this is your responsibility, the customer's responsibility. Because the shared responsibility model says you are responsible for information and data. If you take on some of these services of ours, we'll provide you with the platform and everything for you to be able to use. And we'll, of course, make sure that the security of the cloud platform, the whole entire console is secure for you to use. But for security in the cloud, these are the applications and services you turn on. That's now your responsibility. So the shared responsibility model, the responsibility of security in and of the cloud, this is something that's really, really important to cloud computing. And it certainly will come up for those who may be thinking about taking an exam, fundamental exam with the cloud. So although those are 3 cloud computing models, let's go into a little bit more detail about what they are. So let's start off with infrastructure as a service. So infrastructure as a service is kind of like that. We're going to use an example from Microsoft. When it comes to Microsoft, Microsoft will give us a cloud platform called Azure. So I'm going to always speak about Azure from now on because that's my forte. However, maybe I'll refer to some of the other cloud providers like AWS and GCP in a little bit. So infrastructure as a service, it's a good option for organizations that want to have the most control over the infrastructure and applications, but they just don't want to deal with the physical servers, right? They don't want to deal with the physical stuff, basically. So if remember the whole point of using any of these services, and organizations, what their aim is they will have an application that they've created, right? And they want to be able to build it and host it somewhere. If they want the most control now, right, from top to bottom, then they'll use something like infrastructure as a service. Because if you remember, if we have a look at the model here, we can see that the dark blues you get are in infrastructure as a service. So some organizations might want that. They might want that control. Okay. So they are wanting to host this application. They want the most control. They'll use something like infrastructure as a service. Some of the examples are, for example, virtual machines or servers, could be storage, could be databases, and there are other various services as well. So it's like renting out a virtual machine in the cloud, basically. And you can choose from maybe some pre-configured servers, or maybe you just want to make your own custom server image, basically. Okay. And you want to configure it to make it robust and scalable for your organization. So the main takeaway for you for infrastructure as a service is that it's a good option when you want to have more control over the infrastructure and the applications, but you don't want to deal with the hassle of managing physical servers. Okay, let's go in a bit more detail about platform as a service, PaaS, as it were. This is a good option for organizations that want to focus on actually just building and deploying applications. They don't want to worry about the underlying infrastructure, and they certainly don't want to worry about the operating system, right? They don't want to think about that or worry about it. They want just something to be able to use where they can actually just focus on building and deploying their application. Okay. In Azure, some of the tools we have are, for example, an Azure App Service. That's a tool, that's a service within Azure that allows you to do just that. It gives you the opportunity to build, deploy, scale these web applications, also some mobile applications as well. And you can use a variety of different programming language, could be Python, PHP, Java, whatever it may be, okay, to build these applications. There are other services within Azure as well. For those who want to find out, Azure Functions is another PaaS offering. And that's where you can have an event-driven application. So let's say you might have a script that does something in particular, right? Maybe a YouTube video downloader, for example. That script, that line of code, all is in the Azure function, right? And when something happens, right, a trigger, an event could be on a schedule, could be when someone presses the OK button to download that particular URL. Or that video from that particular YouTube URL, then the script runs on Azure Functions and it does what it needs to do. Kind of the same thing as the previous one, but it is a bit different in terms of management and configuration, but we don't need to go into too much detail there. So the whole point of using something like PaaS is an option for organizations that want to focus on building and deploying applications. They don't want to worry about the underlying infrastructure, and they can take advantage of a range of development tools and services, making it easy to build, test, and deploy those applications quickly and efficiently. Software as a service is something that actually we're all familiar with. This is just a cloud-based, something you can access on the internet, software delivery model. Okay, some kind of third-party provider will host an application and will make it available to customers to access over the internet. Okay, so rather than having to purchase and install a software on your own computer, even on a software, what a SaaS software allows its users to access software applications and data just through a web browser or a mobile app. No configuration is needed for this application, and you're all using it all the time. Your emails, your calendars, all these websites that you're running are on some kind of SaaS model. It's something that you're able to use, some kind of application that is accessible through a web browser or even a mobile app. Okay, and it's often a subscription-based service. So what usually happens is you pay some kind of monthly or annual fee to access the software. Let's make it really, really apt for right now. ChatGPT, for those who may have heard of it, and I hope a lot of you have, is a SaaS-based, subscription-based application, right? It's accessible over the internet, okay? And there is actually a subscription base to it because there is a free model and there's also the ChatGPT Plus model, which is about $20 a month, which is not that bad actually for the things you can do on ChatGPT. All right, so there's a wide range of uses for using something like SaaS. And the main thing for us to take away is when it comes to the shared responsibility model, how much responsibility do I retain? Going from IaaS to PaaS to SaaS, I retain less and less responsibility. You can see those turquoise blues, that's the cloud provider. And you can see when we go from IaaS to PaaS to SaaS, depending on which one we choose, we're giving away more responsibility to the cloud provider. Sorry. So all of them are speaking about this here. We have organizations that are trying to host these applications, these websites, build and manage their infrastructure. Maybe they're trying to analyze data, and there's a whole lot of other things that they're doing as well. But these are typically what some of the organizations are doing. And they're going to be like, well, when I want to use the cloud, how much responsibility do I want? How much control do I want to retain? And so they will choose the right cloud service type as a result. Okay, let's talk a bit about the cloud models now. What we've been speaking about this entire time is what's known as the public cloud. Even though I've just said the word cloud, I just said the word cloud. I didn't say anything else surrounding that, right? The public cloud is literally what you're using what we're talking about right now. Azure, something you access over the internet, and anyone can make an account and access it. They can access whatever services they want to use, storage, database, servers. Maybe they want analytics software. Maybe they want to run some AI or machine learning models, right? As long as they've got an internet connection, they can access it through their web browser, and it's hosted by some other third-party organization. Really, really easy. And it's good because we can take all those advantages and benefits we spoke about before: scalability, flexibility, and much more. But it's not just the public cloud when it comes to the different cloud models. Some organizations actually, they say, and some organizations based on legal or regulatory requirements may not be allowed to use something like the public cloud, or maybe they may be limited in the usage of the public cloud. And so for them, it will be more important to use something that is a bit more private. And that's where the private cloud comes in handy. A private cloud is almost like cloud services that's dedicated for a single organization. No one else can access it. Imagine it being like a private data center that you as an organization own, right? You as an organization own. And it's where you want to have those benefits of on-premises. So you kind of take your on-premises data center and you kind of turn it into an internal private cloud. Okay, so it's good for organizations that want to have more control over the infrastructure, their applications. They want to keep their data on premises, maybe for security reasons, maybe for regulatory reasons. And this is why you may see many government organizations, they are not allowed to potentially use something like the public cloud, because the public cloud has their data centers all over the world. And so it may be the case that the data that this organization holds, they are not allowed legally to have that data in this particular region. Okay, maybe they're based in Germany, for example, and it's not allowed to cross the German borders. Okay, so maybe there are particular requirements when it comes to using the cloud, and public cloud might not be for them, and that's where they may want to use something like the private cloud. Okay, these resources are not shared with any other organization. When you're using a public cloud, you may have the same data center, even the same server sets that might be shared across multiple organizations. Now, they won't be able to interfere with your resources in a public cloud, but it's still shared with other organizations. But when you want a dedicated one, just to you as a single organization, then a private cloud might be something of interest. Okay, but it is, yeah, and it has the same cons as having an on-premises data center or server room. You're going to have all those costs associated with it, right? It's going to necessarily require more maintenance from your side, and maybe a high level of expertise to actually deal with those servers and infrastructures. Okay. But hybrid cloud is somewhere in between. Hybrid cloud is where you can utilize the benefits of both public and the private cloud. So the whole point here is where you want to run some services in the public cloud to take advantage of the cloud benefits, and some services on the private cloud because maybe your organization requires the security or regulatory reasons to use the private cloud, right? So hybrid cloud, the whole point of it is it combines between the benefits of both, achieving and taking advantage of the benefits of both the public and the private cloud, while also addressing some of the limitations of each. If you know that actually this is something that won't run well in the private cloud, maybe I should run it in the public cloud, and vice versa. Okay, so an organization, they can host some in the private, and when they want to take the benefits of the public cloud, they can host some of their services in the public cloud. All right. So now let's talk a bit about the architectural components. What does this mean when we talk about architectural components? I should just mention as well, you might notice that there's a lot of detail on these slides. Whenever I actually deliver courses like this, I try to keep less information on here, but I thought Banu is hopefully going to share these slides with you. So for anyone who's actually interested in studying a bit more about it, maybe you're studying for a cloud fundamentals exam, this kind of information will probably come up in your exam. So I thought, okay, well, if we're going to share it, let me put a bit more information on the slides and actually make it useful. So don't worry if you can't read through all of this during the time right now. That's okay. I'm trying to go for it as much as I can. So I might skip over some stuff, but that's okay, because hopefully you're going to get these slides to you. Okay, cloud architectural components. We saw that we could deploy in what different ways? 3 different ways. Okay, when we come to the cloud, we want to have infrastructure as a service, platform as a service, or software as a service. That kind of just defines for us from an overview, bird's eye perspective, what the cloud service types will look like. But if there's a particular kind of service that we want, right, that delivers a particular type of promise, then that is where we need to look at the architectural components. Okay, this could be, for example, we may need a compute service. We may need something like a compute service, right? In a compute service, this is basically where you're given like the hardware basically, and you get some configurability on that. Maybe you're given a platform to work on as well to run your application. There is some kind of processing of compute hardwares using something like a compute service. Storage makes a lot of sense. A lot of us use cloud storage without even realizing. If you've got an iPhone, you're probably using iCloud, right? Maybe a lot of you are using Google Drive. Maybe a lot of you are using OneDrive, for example. Those are cloud storage services, and you're using that for a very particular type of situation. So an organization, maybe they're building an application. This application uses multiple different facets and features together. Maybe they take some information that someone enters and they store it somewhere. Maybe they store files that people upload, right? Where would they store it? They need to store it in some kind of cloud storage solution. And you can see here, when it comes to storage, we may have object storage, also known as blob storage. This could be like files and images and videos, even documents as well. And that can be fed to a user in a website, for example. So if you go to something like Nia.ai or Sports Direct or ASOS, whatever, those files, those images and videos that are fed to you, they're stored somewhere. They're not just there, you know, they're fed to you. And so they need to be on some kind of cloud storage potentially. Cloud storage is certainly really, really important when it comes to architecting our application. Networking might be really useful as well for trying to build an infrastructure, just like we had on premises, where all these computers were kind of wired up to each other so they can communicate. Then the networking is really important to allow that communication. That's the whole point of having networking. So cloud networking is where you don't need to physically get the Ethernet cable and plug it into a router or, you know, connect it to switches, etc. It's kind of doing all of that virtually. That's what's known as virtual networking. And you can create these virtual networks, these pools of resources that can communicate one to another, right? Maybe you can even talk about when there's demand increasing to access your website, how can that load be balanced across multiple other backend servers? All about networking, all about communication. This is what networking services can certainly allow for you. And not just networking between these services, being able to access these services over the internet. There is some kind of networking involved there too. Databases are really important as well. Okay, we're not going to speak too much on this slide, but database is certainly something really important for organizations that hold data. They may hold it in some kind of database, a relational database, or maybe NoSQL database. Okay, being able to manage and store that data somewhere for them to access, to query, to be able to get meaningful information out from it. Okay, and certainly analytical stuff as well. If they want to actually process that data that they have, be it in those databases or otherwise, they may want to actually find out more information from that data. So using some kind of analytical tool, maybe even a machine learning tool, for example, could be something that is very, very important for them. And there are other, by the way, other components. You can call these the core components of the cloud, but there are other components that the cloud platforms like AWS, Azure, and GCP offer for us. When it comes to actually deploying in the cloud, an organization, they need to think about what is the best way to do it. They're not just going to go about making an account in the cloud straight away and then just start building random things. It actually comes with a process. You may see these words like well-architected framework, okay, things that actually show you what are the best ways to actually begin deployment into the cloud. It's just not just to start off on a whim. There is a lot of planning involved, okay? Planning and design, for example, if you look on the right-hand side, that is a step that involves assessing the organization's needs and goals, and then designing an infrastructure that meets those needs. Maybe you need some kind of virtual networking. And associated with that, maybe you have servers that host applications that run your organization. Maybe you have storage attached to that because you need to store particular things from those applications, and so on and so forth. To architect something, and for those who actually are looking to get into the cloud, have a look at a cloud architect role. I know AWS actually recently put up a role for a cloud architect intern. So that's something maybe for a lot of you might be interested in looking at. All right, but an architect, typically they look at what your requirements are, and they say, this is how I would build this entire infrastructure, this architecture in the cloud for you. Second step would be to implement and then maybe even migrate. Maybe we have some stuff on premises that we're trying to move into the cloud and take advantage of the cloud, right? And when we say the cloud, we're talking about the public cloud in this particular case. So that involves implementing the cloud infrastructure, migrating data and applications to the cloud. Then you may want to test it, optimize it. You want to make sure it's tested and optimized for performance and cost. And then under operations and management, you want to make sure you're maintaining it and managing that cloud infrastructure so that it remains secure, reliable, and cost effective, right? And on the left-hand side, you can see there are some additional deployment processes here. So in terms of defining requirements, that kind of fits into the planning and design section, finding out what are the requirements for this application you're trying to run, or this service that you're trying to deploy in the cloud. What are the different compute, storage, networking, and database resources required to support the application or service? You probably want to choose the right cloud provider to do that. And a lot of people think that, okay, I'm just going to go to one cloud provider. One thing we didn't speak about in the different models is there's also a multi-cloud model. And a multi-cloud model is where an organization may use multiple different public cloud providers to do their service. They may run some database services in AWS. Maybe they're running some compute services in Azure. And maybe they're running machine learning services or data analytics services in Google's cloud platform. And it is very common for a lot of organizations to actually be using multiple different cloud providers rather than just stick to one, okay? But once you've defined that, you would move on to actually configuring those cloud resources. Maybe you'll go into something like Cloud Engineer. So I used to work as a cloud engineer. The architect would produce these diagrams and they'll say, this is exactly what we need to produce. Here you go and do that. So as a cloud engineer, what you do is you'd actually go about actually deploying it to the cloud, right? Configuring those resources. And then after configuring the resources, you'll deploy whatever application or services that are required as part of those backend resources that need to run those applications. And then, like we just mentioned, you need to monitor, for operations, you need to manage these services now. Once it's been deployed, it's important to make sure it's running well, it's running smoothly. It includes monitoring resource usage, applying any updates or patches that you need to, and even troubleshooting any issues that arise. And some of the issues that arise could be from a security perspective. We need to understand when it comes to security, it is a huge concern for an organization, right? As part of their monitoring and management, but also throughout the entire configuration section, even in the planning section and design section, okay, to include data security, identity and access management, compliance, service availability, the security of the cloud provider itself. These are concerns that are important for every organization because they need to ensure, hey, this data that I'm putting into this cloud, this application that I'm putting into the cloud, is it secure? And have I made sure it's also secure in the cloud platform that is hopefully also very secure as well? Let's speak about just one or two of these. We won't speak about all of them. Identity and access management is a really, really important one. That second one that you see there. That's talking about who is allowed to authenticate, to get access to the building, as it were, right? And who is allowed to, and when you authorize that authenticated user, what are they allowed to see, touch, and do, right? Typically, when we talk about identity and access management, we talk about rights and permissions, what people are allowed to access, what resources are they allowed to use. And so that's a really, really important part of building and designing an organization in the cloud. It's about making sure that, okay, we've put these things into the cloud. Now, we can't just let anyone access them. We need to understand who's allowed to access them, what roles and permissions are there to limit access where people are not supposed to get access to things, right? So you may hear the words least privileged access. Although this is not a security course, we would probably go into more details if it was. But least privileged access says only give someone just enough access for them to do their job at the time they need it and for how long they need it for. Those are principles associated with that. Compliance is also really important too. If this organization needs to stay in compliant with a regulation in that region, or maybe just a global regulation based on a law, for example, or a framework or a standard, then the cloud provider itself needs to provide tools so that that organization can stay compliant according to those regulations. And this is where you actually get into more of the nitty-gritty, maybe less technical side of things, because this side of things, you'd get more maybe the legal team, the compliance teams of an organization to deal with that kind of stuff. Are the resources that we have in the cloud, are they compliant with that framework that we're supposed to follow? Are we following GDPR, for example? Are we following some other kind of security compliance? Because we may be liable to the legal, to the legislation that is surrounding that regulation, for example, right? So these are really some important security concerns to speak about. And there are also solutions based on that too. When it comes to encrypting data, we need to ensure that we are encrypting our data if the manual option is there for us, but also have we turned on a service in the cloud provider to encrypt the data at rest, in transit, okay, before it's into the cloud, while it's in the cloud, while it's moving around the cloud, right? All of the things that we just spoke about in the concerns, there are some solutions that are provided by the cloud provider to tackle them. For example, in identity and access management, using something like multi-factor authentication, right? Using something like multi-factor authentication. Sorry, I thought there was a question in the chat. Compliance as well, sticking to a particular requirement such as the HIPAA, GDPR. So to disaster recovery, what if something was to really go bad? How can we recover our data, right? How can we look at backup, site recovery, data replication, and much more? And these are services that the cloud provider provides to you automatically when using the public cloud, but also some additional services that you pay a bit more for to get a bit more on those kind of services, preventing data loss, for example, or service disruptions. Okay, oops, there you go. So let's have a look at some example services that actually use cloud computing. I know we're reaching our time, but almost at the end of our slides. Cloud storage and backup, we're going to speak about more of the common ones that you might see right now. So these are ones that are using and examples of cloud computing services or services that have some kind of cloud computing in the background. But we're not talking about the very particular service you'd go into Azure and deploy right now. Does that make sense? Because what I want to get from this is that every single person here you are using a cloud service in some way, shape, or form. You are. Even if you're not going to the cloud provider and saying, can you give me a server? A lot of the things you do right now are utilizing cloud computing. Look at Dropbox, look at Google Drive, look at OneDrive, for example. That's cloud storage. And whenever you want to back up your phone, you're probably using iCloud if you have an iPhone, for example, right? Collaboration and communication. Tools like Teams and Slack all utilize the cloud in the backend. Okay, how do you think it works all over the internet for us to be able to use it? E-commerce and online marketplaces such as Amazon and eBay, especially Amazon, because we know Amazon's biggest cloud is known as Amazon Web Services, right? So in the background, how is that website running? How is it able to store all those pictures of the products and the descriptions of them, right? How is it able to feed that to you really quickly when you click on that? So all running cloud, some kind of cloud computing in the backend. Same with some kind of mobile apps in games as well. They might use it for enhancing their services through data storage, maybe even processing to make the user experience a bit more connected. For those who play like console games, you may have a lot of online only games, meaning you'll download it to your PS5, for example, but you have to be connected to the internet to take advantage of some of those cloud computing services, basically. And so maybe if you run something like Destiny 2, you know, that is a purely cloud only game. You can't run that offline, right? You can't run that offline. You have to be connected to the internet, right? That's because you're using some kind of cloud in the background to provide a user experience there. Okay. Cool. We'll spend a little bit on this on this slide. So whenever it comes to industries now, so let's talk about healthcare, for example. Healthcare might actually specifically want to use the cloud to provide a particular type of service, maybe the actual health records. Now, I know recently the NHS have, and the government in its entirety are trying to actually move into the cloud to take advantage of the cloud. So for those who may actually begin to work with those organizations, something maybe in the government, something with healthcare, you might actually realize that a lot of those systems aren't old anymore. Some still are, don't get me wrong, because this is what happens when you work for, public industry like healthcare and government. But they will have moved a lot of the systems into the cloud because they want to take advantage of those cloud benefits. So you might have your electronic health records there, telemedicine platforms, etc. For finance industries, a lot of their trading platforms will be cloud-based, right? Even their risk management software, for example. Retail, very easy, the point of sale systems, the inventory management software. Education, you have a lot of learning platforms, again, based in the cloud. They want to be able to take advantage of this global nature of the cloud. So let's say, for example, you host something in, maybe you're a UK-based company, but all of your customers are based in Australia. So maybe you can spin up some servers in an Australian data center, so it's close to your customers. So there's less latency and they're able to access these websites and applications quicker, right? And especially when it comes to a lot of these platforms, they want that quickness. They want that quickness to it, decreasing the latency associated with people and their customers using their applications, right? So the whole of these examples demonstrate the ways that cloud computing is actually being used in specific industries to improve efficiency and effectiveness. A couple of the last things that I just want to mention, there are some trends associated with the cloud right now. A lot of organizations, when they use the cloud, they go multi-cloud and hybrid. Okay, because they might already have an on-premises infrastructure and they might not be able to let it go because of the way it's they've configured it or architected their on-premises servers, for example. So they may say, you know what, we'll utilize the cloud as well and connect these two environments together, taking advantage of both the private on-premises, private cloud, and maybe also the public cloud to take advantage of that. Maybe they're also using multi-cloud, like we mentioned earlier, for cost purposes. Maybe a particular service is better on one public cloud provider than another. Serverless, we kind of spoke about it a little bit earlier when I spoke about Azure Functions, but it's basically where you don't even think about underlying that service. There's actually a computer. Underlying every service is a computer running something, but how much is shown to you is what's really important. With serverless computing, basically nothing is shown to you. You don't need to worry about the underlying infrastructure at all. It will automatically scale the resources as is needed based on that demand. You don't even need to worry about anything. You just need to worry about, as a developer, writing and deploying your code as and when you need it. Okay, and some additional things as well, like edge computing. Kind of spoke about that a little earlier, putting things closer to customers, for example, to make and reduce latency, improving that user experience. Artificial intelligence and machine learning, huge topics right now. And it's not just ChatGPT, OpenAI, who are, Midjourney, for example, who are using AI-based things. Actually, these cloud providers, public cloud providers, have their own AI and machine learning services, right? Microsoft recently signed some $1 billion deal with OpenAI, and they're going to implement the OpenAI service across many Microsoft services. So actually, very soon, you're going to start to see the Azure services that utilize AI actually take advantage of that OpenAI database and services that OpenAI have been working on for the last little bit. Okay, so AI, machine learning is something really, really big in the cloud right now. A lot of organizations are taking advantage of that. And cloud native architecture basically talks about designing everything specifically for the cloud, using things like microservices, containers, Kubernetes, other cloud native technologies such as that. If you want to learn a bit more about cloud native technologies, I believe it's called Cloud Native Foundation. Is that correct? The Cloud Native Foundation? Yes, CNCF, the Cloud Native Computing Foundation, which I will send into the chat in a little bit because it's on a different screen. The Cloud Native Computing Foundation, where you can learn a bit more about all of the different services that are, when you want to build things to take advantage of the cloud, here are the kind of services that you can potentially use there. Okay, and what could be the future of the cloud? What are the things that we're going to see? We're certainly going to see more AI and machine learning services. That's the big buzzword right now. The big buzzword right now. We're going to see a lot of edge computing, with 5G being much more mainstream. It's still not fully mainstream, but it's being much more mainstream. You're going to start to see that be a huge part of a lot of organizations' infrastructures. Okay, bringing that data closer to the end user to be able to use that. Although this should have really been there from the start, increased focus on security is certainly going to be something that is going to be much more at the forefront of people using the cloud, because of all those organizations that are just leaving their S3 buckets open all willy-nilly. So they need to get a big kick up at the backside to say, no, security is really important. You should also be building with security in mind, not just having security as an afterthought. Okay. DevOps is actually a huge thing right now. I actually predict this will go even further. It's already evolved into DevSecOps right now, but all of these terms, they're very blanket and vague. They start to evolve and mutate, and they change their meaning every 6 months or so. For those who are thinking about a career in DevOps, try and define it. You probably won't be able to, but there's the whole point. In the future, the cloud and all these DevOps tools, although they are already, they'll become more and more integrated and intertwined. And certainly we may see in the short-term future, this increase in using containers and Kubernetes. We're already seeing it right now. In the last couple of years, that is what we've been seeing. A lot of organizations saying, we don't need to use containers. They don't really know why, but they know that it's the next big thing. And so it's certainly going to be a lot of organizations getting more clued up. If you start to see job descriptions, which I kind of do daily, a lot of these cloud engineer roles may actually ask for experience and having used Kubernetes, some DevOps tools, containers, etc., etc. Of course, I'm being vague here, but certainly these cloud native technologies surrounding that are going to be more and more asked for by organizations, and they're using it more and more. It's not taken up overnight. All right, and that's pretty much the end of that. To summarize, cloud computing is all about taking all those hardwares, throwing it to someone else to deal with, because we don't want to deal with that, and just saying, can we just rent out the servers and stuff like that? All your services, can you just, let us pay for the service we want to use, okay, rather than have to pay for these big computers ourselves and decide what we want to do with that and configure it, maintain it, and deal with the costs associated with that. Cloud computing is giving that to someone else, and we access it over the internet, and we pay for whatever we use on a consumption-based model. Right? Thank you very much, everyone.